Hi everyone. For this video, we're going to go over finding the inverse of a function. Follow the steps below to find the equation for the inverse of a function. So the first step is that we replace f of x with y. Now, sometimes functions are named other things like g of x or h of x or, something of x. But whatever you have your function named, you are going to replace that with y for your first step. The second step is that we interchange x and y. The third step is that we solve for y. Fourth step, if the equation for y represents a function, we replace y with f inverse x. So this notation right here, this is read as f inverse x. It's not an exponent of -1. This is just the notation that we use. And for the last step, you want to check that f of x and f inverse of x are indeed inverses by composing them with each other. So if they are inverses, f of f inverse of x is equal to x, and f inverse of f of x will be equal to x. So it doesn't matter which one you compose inside the other. Either way, if they have that inverse relationship, the output will be x. Now let's go ahead and practice using these steps. So we're going to practice using the steps with the function that you see graphed here, which has the equation f of x equals 3x plus 2. But before we go ahead and proceed with the steps, let's just make sure that you understand what inverse means. So if you look right over here, inverse means that we are interchanging x and y. Something to keep in mind is that sometimes your inputs and outputs, or your domain and range values, may not be x and y. So maybe a better way of putting it is to say that inverse means that we're interchanging the input and output. Or maybe just easier to understand, we can write down that we are swapping the input and output. So that's what I'm going to write down. Now just make sure that you understand that it does not mean the opposite, which would be switching signs from negative to positive or positive to negative. And it does not mean the reciprocal, which would be flipping the fraction. So let's go ahead and write that down too. So again, the inverse means swapping the input with the output. It does not mean the opposite, which is changing the sign, nor does it mean the reciprocal, which is flipping the fraction. So let's go ahead and proceed with our example here. So we have here that f of x is equal to 3x plus 2. If we look back at our steps, the first thing that we want to do is replace f of x with y. So let's go ahead and do that. And I'm going to go ahead and just number my steps here. So I have y equals 3x plus 2. Now we go to the second step, which says to interchange x and y. So again, that just means that we are going to swap x and y. I'm just going to go ahead and write it down for the second step. So we have x equals 3y plus 2. Now be careful at this step. I've seen a lot of students that will switch the entire product here of 3x with the y. So they'll swap the entire product out instead of just switching out the x and a y. And I think they just do this because they think that it's, you know, the 3 being connected by multiplication to the x, that you can't, separate it. But that's not the case. You can actually just switch out x with y, no matter what operation is connecting them. So that's the second step. Now let's look to see what our third step is. Third step is to solve for y. So what I always do here is I'm thinking ahead, and I know that I want to have y equals something when I'm done solving. So I'm going to go ahead and put 3y plus 2 on the left as my initial step in solving, and I'm going to put the x on the right. So I'm just switching sides. And then the next step in the solution process will be to subtract 2 to undo the adding. So I now have 3y equals x minus 2. The next thing that I need to do to isolate y is I need to divide by 3. And that's how I'm going to undo the multiplication that we see there. So I have y equals x minus 2 over 3. Then I'm going to go to my fourth step. So let's look back and see what that is. So the fourth step is that if the equation for y represents a function, we replace y with f inverse of x. Now, how do we know if it's a function? Well, if you have a single y equaling some expression with x. We'll see an example in a second where it does not represent a function, and so we don't have an inverse function. We just end up with a relation. And then in that case, we will have to restrict the domain of the original function. But that's for the next example. But here, this is a function. Y is equal to a single expression of x. And so since the inverse is a function, we can go ahead and write it in inverse function notation. So I have f inverse of x is equal to x minus 2 over 3. And now we need to look at step 5. We want to check that f of x and f inverse of x are indeed inverses. So we compose them with each other. And we want to make sure that when we compose either way, if we take f inverse of x and put it inside f, or if we take f of x and put it inside f inverse, that we get an output of x. And I'm color coding this for you so it's easier to understand. Notice here that I have f of x in green and I have f inverse of x in blue. So we'll keep with that. And I'm going to do f of f inverse of x first. So I have f of f inverse of x is equal to that will be f of, well, f inverse is x minus 2 over 3, so we're going to substitute that in. And really, as long as you know how to substitute, you should be able to check your work with accuracy. So this is f of x minus 2 over 3 now, since that's what f inverse is. And then this equals, well, since f of x is 3x plus 2, so we have 3 times something plus 2. Well, that's something that x is going to be replaced by x minus 2 over 3. So we're going to have 3 times x minus 2 over 3 plus 2. And then we can simplify. So these 3's right here cancel. And I have x minus 2 plus 2, which equals, well, the minus 2 and plus 2 are going to cancel. And that equals x, which is what we wanted. All right, now let's go the other way. We're going to do f inverse of f of x. So f inverse of f of x that equals f inverse of, we're going to substitute the equation for f of x in here. So we're going to put 3x plus 2 and that equals, well, f inverse is the quantity of x minus 2 divided by 3. Now, in place of x, we're going to have to put f of x, which is 3x plus 2. So let's go ahead and do that. So we have 3x plus 2 and then we write down everything else exactly as it is. So we have minus 2 and then divided by 3. These 2's will cancel here. And so we get 3x over 3 and then the 3's will cancel. And this equals, as expected, x. So this proves that they are inverses of each other. So that means we did our work correctly on those first 4 steps. So let's go ahead and just write down our answer over here for the inverse equation. So we have f inverse of x is equal to x minus 2 over 3.